The world of energy is changing nowadays, and we need to face the necessity to shift away from fossil fuel towards renewable energy sources. This aspect, together with the advance in the field of ICT, is moving all of us toward the smart grid. A grid that will use technology to improve its resilience and increase the service for the customer. This evolution, however, needs to take into account different challenges, such as the management of renewable energy sources, the distributed generation, and the increase of power demand from electric vehicles. In addition to that, new actors and new business opportunities will enter in the energy market. I'm Matteo Orlando, and my research at Politecnico di Torino focuses exactly on some of these aspects that I will briefly explain in this video. Nowadays, there is a huge necessity to shift from fossil fuel towards renewable energy sources, and PV panels are one of the most promising technology, since they are cheaper to install and easier to maintain with respect to the others. We also need to take into account the appearance of new actors in the energy market, such as the prosumer, that is the customer that can both produce and consume energy, and the renewable energy community, that are a group of prosumers that organizes together to share a common renewable energy system. Therefore, my research aimed to provide a framework for the economic analysis of PV system targeted toward prosumer and renewable energy community, to help them during the planning phase. With my first work, I was able to use early weather data and GIS technology to avoid or if possible exploit the shading effect on the PV panels to improve their power generation. With this work, I was able to produce new panel configuration with the same amount of panel of the traditional one, but capable of producing more energy. However, in this case, the work was focused only on the prosumer perspective, since we analyzed a single roof. So, with the second work, I allowed the possibility to deploy and connect panels across different roofs to take into account the renewable energy community aspect. Also in this case, I analyzed the impact of the number of panels on the power production with cost and benefit. With my last work, I was able to improve the previous framework, allowing the possibility to evaluate systems with different panel orientation and using real census data and real consumption data to simulate the energy behavior of the renewable energy community to better evaluate the benefit. I was also able to evaluate the reduction in carbon dioxide emission due to the usage of renewable energy sources. In order to have a proper smart grid, we need to increase the metering and automation capability of the grid to increase its resilience. Nowadays, meters are mainly used for billing, and the automation of the grid is extremely low. In order to solve this issue, we proposed a three-phase smart meter prototype together with a smart metering architecture, capable of provide automation for outage management and provide communication infrastructure in order to perform cloud computing, edge computing, and fog computing. The prototype is composed by a Raspberry Pi and a data acquisition board and uses REST and MQTT communication. Together with HDMI, it's able to perform self-configuration and auto-update procedure, and is also able to run fault detection, fault location, and state estimation algorithm. External service can also be included in the advanced metering infrastructure. Both the prototype and the advanced metering infrastructure were tested using co-simulation technique. Real-time simulators were used to simulate the behavior of the real electric network, and a metropolitan area network simulator were used to test the communication part. All the tests were performed using hardware in the capability of the meter that was able to have a fast fault detection and location, reducing the amount of time needed to re-energize the network from the 40 minutes needed at minimum nowadays to only 10 seconds. We were also able to assess the resilience to the network congestion of the whole infrastructure.